Hello, my name is John Mills. I'm Director of Data Enclaves for the Coleridge Initiative. In this video, I, along with my colleague John Kearns, will be providing an overview of the Administrative Data Research Facility, or ADRF. This is Coleridge's secure, cloud-based data hosting platform that encourages collaboration and innovation among public agencies and researchers. The content for this video was presented in September 2023 at the first session in Coleridge's new Data for Evidence Building webinar series. Over the past few months, we have been working diligently to enhance the way we communicate about Coleridge's ongoing efforts with government agencies. Our aim with this webinar series is to facilitate conversations that drive effective policies for the greater good. This is a quarterly webinar series that will continue with our next session in January 2024. More information on this next session will be shared in the upcoming months. We believe that we can create positive changes by exploring key questions and discussing essential topics related to data and its impact on policymaking. At the Coleridge Initiative, we are working to facilitate the use of data to more effectively inform public decision-making. Our goal is to harness the power of data through strategic partnerships and collaborations with government agencies. We aim to create exceptional value by linking data sets, thus enabling better decision-making. We achieve this goal by developing cutting-edge technologies that ensure the secure access and sharing of confidential microdata. The ADRF plays a pivotal role in this effort by empowering researchers and government agencies to collaborate effectively for the greater good. So what is the ADRF? The ADRF is a secure, cloud-based, FedRAMP authorized platform that promotes access to and discovery of sensitive, confidential microdata. This secure infrastructure enables us to leverage state and cross-agency data sharing, ultimately leading to the development of state-owned and administered data environments. Security is a central focus in our approach. The ADRF infrastructure is built on the 5 Safes data security framework, which allows agencies to safely access and link their data while enabling collaboration. The 5 Safes are safe projects, safe people, safe settings, safe data, and safe exports. Safe projects. The ADRF contains only agency-approved projects that have been proposed and agreed upon by project and data stewards. These approved projects require signed agreements, and only approved users can access the project workspaces within the platform. Safe people. Only approved researchers are permitted to access project workspaces and their related resources. Safe settings. The ADRF is designed to provide secure methods of data transfer for agency microdata, specifically data that includes personally identifiable information. Only agency-identified and authorized personnel are invited to perform data transfers. Safe data. We have developed a standalone Windows-based application to help simplify the hashing of data prior to their transmission to the ADRF. And safe exports. Users are prevented from unauthorized removal of any information within the secure environment. In summary, the 5 Safes framework, safe projects, people, settings, data, and exports, serves as a cornerstone of our secure data access approach within the ADRF. These safeguards ensure that data is used responsibly and securely while fostering collaboration among agencies. The ADRF has many features, but at its core is its permissioning structure. Researchers access the data through isolated project workspaces. Data are held in secure environments within the ADRF and are made accessible to individual researchers as well as teams of researchers according to the access rules that have been determined by the data owners. Data owners are the key here. They determine what data can be available, who can access those data, and under what conditions and for what purposes, and they dictate the required disclosure protocols. Anything that is to be released is subject to the rules provided by data owners. This is accomplished through the ADRF's permissioning structure. From a user's perspective, however, the ADRF simply looks like a typical Windows operating environment, albeit without the internet access. So next, we'll go ahead and log into the ADRF to show you around the environment and give you a sense of how this permissioning structure works in practice. One accesses the ADRF through a web link, which I like to save here on my bookmarks bar. By clicking on the link, I'm taken to a landing page that displays the different workspaces I have access to as tiles. Note, for the purposes of this demonstration, I've already gone ahead and logged into the ADRF. We use multi-factor authentication for access and provide all the setup instructions to incoming users in an onboarding email. The first time an individual logs into the ADRF, they'll see a single tile on the screen, the data stewardship tile. All new users to the ADRF must complete a series of brief onboarding tasks that cover some of the security protocols in place in the ADRF. These tasks are completed in the data stewardship app, and information on this process is provided to users in our onboarding materials. For this demo, I'll be accessing the CI demo workspace. Let me go ahead and click on that tile to log in. This is an environment that we've built using publicly available data that we can use to show some of the features of the ADRF while avoiding the possibility of a disclosive event. So I clicked on that link or that tile, and that brings me to the CI demo workspace. Again, I've already logged into the ADRF for the purpose of this demo. In general, users are asked to provide their password and will be asked to complete a brief security quiz each time they relog into the ADRF. After they've completed this quiz, users can now access the ADRF environment, which we can see here. The first thing a user sees when they log into the ADRF is this open Google Chrome page, the ADRF Getting Started page. This includes links to helpful applications and content for ADRF users. For example, we see some general user documentation, information on SVN, which is a version control tool that we employ in the ADRF to help with coding and attribution, and a link that allows users to request exports from the ADRF. I'll talk a little more about this last feature, the ADRF's export request module, later in this demonstration. We'll note that the ADRF is a secure system, so one cannot generally access the internet through the ADRF. The Chrome application can be used, however, to read PDFs and for this supporting material. So let's go ahead and take a look at the desktop. For PC users, this should be familiar. This is because the ADRF is built on a Windows operating system. You can see some of the applications that are generally available to users on the desktop. For example, we have statistical applications, R, Python, etc. These R and Python come standard, they're open source. We also have Stata as an option. We have our database access tool, dbeaver, which users can use to access structural data. We have Jupyter Lab, which is a cool development environment that allows users to build code and output simultaneously while interfacing with the available statistical packages. And you can also see LibreOffice. This is an open source equivalent to Microsoft Office that comes standard to all users. Just as I would on my home computer, if I wanted to access any one of these tools, I could simply click on an icon to get started. So let me go ahead and do that with RStudio. You can see that just as it would on my local computer, I click on the icon and it brings up RStudio and I'm ready to get coding. Next, let's check out some of the features of the ADRF's file system. I'll go down here and to the folder icon on the main taskbar, and you'll be able to see the ADRF at a glance. Here you can see 4 drives available, the G, L, P, and U drives. The P, or projects drive, contains project workspaces in which research groups can conduct their work. All members of an approved project workspace have read-write privileges to this folder. This means that teams can organize their work just as they would in their on-premise facilities, using their own preferred methods for workspace organization, code development, deriving data, documentation, and sharing their work. Each user also has read-write access to their own personal folder, which can serve as a place for code or document development before sharing it with the broader group. The user's personal folder is located in the U or U drive. Again, access is determined by the data owner. They will let us know who is allowed to access a project workspace and have user folders in the ADRF. The L drive is for libraries that may not commonly be installed for the available statistical programs, like R, Python, Stata, etc. Users can reach out to our support team at support@coleridgeinitiative.org when they want a package added to the L drive. Data that are provided by data owners are stored in one of two locations in the ADRF. Unstructured data, such as CSVs, Stata DTAs, SAS data files, are stored in the G drive. Project teams have read-only access to the data folders in that drive that they've been approved to access. So I can click on this folder's data, and we can see a series of CSV files that have been made available to this project workspace. And again, these are publicly available files that we're using for the purpose of this demonstration. Structured data, or data that are stored in relational databases, are stored in AWS Redshift, a massively parallel processing, or MPP platform that is built on SQL and is specifically designed to handle larger data sets. Users access structured data either through dbeaver, our database application tool, or by porting directly to Redshift through their preferred statistical package, like R and Python. Note, this can be customized for the needs of the data owner. The key is that data are stored in a secure environment and then are permissioned to users through their project workspaces. Data owners determine who gains access to what data, as well as the conditions for access. So again, there are two ways that one can access structured data in the ADRF: directly through a database tool, or by porting in to the data through one of the available statistical packages, R, Python, etc. Users on some projects may want to access their structured data directly in Redshift. Perhaps they want to create standardized views for their research team for commonly used data assets. In that case, they'll want to access these data directly through dbeaver, our database access application tool, which you can see here. So let me go ahead and open up the dbeaver application. Again, the structured data here are stored in AWS Redshift, which uses massive parallel processing and compression to decrease query execution time and to allow Redshift to perform operations on billions of rows at once. For the end user, this means it's very fast. For this demonstration, I'll pull up the public use data that you just saw in the G drive. We've hosted it in Redshift for this demonstration. So that's in DSCI Public 01. And we can look at some of these data as they're public. And so let's go ahead and open up the load CA WAC file. So again, Redshift is very fast. That table has 240,000 records and it opened up in less than a few seconds. And so Redshift has really helped improve the user's experience as we've moved into this new tool. And Redshift itself is based on Postgres. And we have documentation that's available to users to help them with scripting code if they're working directly with the data through Redshift. Alternatively, many of our users prefer to pull from Redshift using one of the available statistical programs. If I went back to the projects folder, we have some code in our connecting to data folder that our team has provided that allows individual teams to pull data directly in using R. I'm actually going to go ahead and demonstrate this using Jupyter Lab so you can get a sense of how Jupyter allows teams to draft code and report output simultaneously while they're working. So here we have a Jupyter Notebook file. Let me go ahead and execute these first few lines of code. And what this is doing is pulling in the data directly into R that are stored in Redshift to allow the research team to code directly off those data. We also have, I can also show that you can just read in data directly from the G drive. That's what this code is doing here. And you can see it's the same data that were present in the dbeaver application that were present above. They can pull them in directly from the G drive because they were also stored in the G drive. We can also see how Jupyter allows for text, code, and output to be embedded directly into their notebooks. So here, let me go ahead and create a histogram plot. And you can see that the code is being applied directly to those data, generating an output file. And so Jupyter is a pretty cool tool that allows one to both code and produce output simultaneously while you're working. Now, when I'm ready to export something from the ADRF, I have to use the ADRF's export module. It's available to users on the Getting Started page, which we saw when we first logged into the ADRF. The export module is right here in the upper right-hand corner of the Getting Started page. When I click on this icon, it brings me to the module itself. And with the export module, you're essentially creating a ticket in our system that helps kick off an export review. So I can do that by clicking on New Item. And I'm brought to a new screen, which walks me through some of the required elements for this export. I can upload files through a simple drag and drop that I want to actually export from the ADRF. I can also upload some export documentation that our reviewers and data stewards can use to complete the review. And this brings us back again to the 5 safes, or more specifically, the 5 safes concept of safe exports. Again, nothing can be exported from the ADRF without undergoing a review. And the export or disclosive review protocols are determined by the data owner. There may be cell size limits for aggregate tables, etc. The specifics of the export review process are dictated by the data owner, but they typically occur in 2 stages. First, members of the Coleridge team are notified by the export module of an export request. And a member of our export team will provide a cursory review of the provided documents to ensure that they align with the data export's protocols. For example, they'll verify that all summary tables meet the required cell size limits, etc. Any flagged issues are sent back to the submitter for resolution. If the export passes the cursory review, the request will then go on to the data steward, which is usually a designated staff member from the data owner agency. The data steward performs a final in-depth review. This 2-step process works to minimize the possibility of a disclosive event. The export is only released to the requester after it passes both stages of the export process. Once passed, the requester will receive the exported files through a secure email. This, however, is just an example. We're happy to work with data owners to determine which export protocols work best for them. So to sum up, in this demo, we've logged into the ADRF and taken a brief tour. Note, the ADRF is built on a Windows operating system, which means navigation is familiar to most users. The core of the ADRF, however, lies in its permissioning structure, which allows data owners to securely permission data to specific users for approved projects. Again, the data owner is key here. They identify the data that are available to access, approve users and projects to access those data, and provide the rules needed for exports from the ADRF. Next, I'll hand it off to John Kearns, our Associate Systems Engineer, to talk about our management portal, which allows users, project leads, and data stewards to monitor usage.
My name is John Kearns, and I'm an Associate Systems Engineer here at Coleridge. Today, I'll be showcasing the ADRF Management Portal, which was recently launched in June of 2023. This is our in-house reporting and utilization dashboard that allows researchers to view key insights about how they're using the ADRF. Throughout this demo, I'll showcase the features that are available to all researchers. However, if you are a project lead, I will also point out a few key differences that are available to you as well. So let's get started. From my Okta dashboard, as you can see, I have an ADRF Management Portal tile. To log into the Management Portal, all I have to do is click on the tile. For the purposes of this demo, I've currently masked my account as Uni Lee, a researcher here at Coleridge. This allows me to showcase the Management Portal as a researcher would see it. So here, we have the insights for compute hours, user storage, unstructured storage, and structured storage. Let's take a look at this first tab, compute hours. Here, Each row displays the total hours spent within a project workspace during the time period. In this case, there's a monthly quota of 50 hours for the time period of 2023 April, and we've used one of our 50 hours. As you're approaching the quota, this green bar will turn yellow, and if you've gone over the quota, the bar turns red and shows you the overage. This second tab is for the user storage. When you get added to a project workspace, you get assigned a user folder on the U drive. This is your own individual folder where you can save your scripts, your documentation, etc. Each row here displays the usage, which is the size of the user folder, compared to your predefined quota for user storage. As a side note, if you're a project lead, then you would be able to see the compute hours and the user storage for not only yourself, but each researcher within your project. This third tab is unstructured storage. This is a combination of our P drive and G drive storage. The P drive is home to the shared project folder, which is used to collaborate and share files with other researchers within your workspace. The G drive is home to the read-only flat file datasets attached to the workspace. Each row has the usage for these folders compared to the predefined quota for the unstructured storage. The usage bar is color coordinated, purple for the P drive and blue for the G drive. This last tab is structured storage. This is the Redshift storage, and it contains the storage that's being used for the read-only relational datasets attached to the workspace and the shared project schema. So, to summarize, the insights can be viewed from two different scopes. On the left, you have your user scope, and on the right, you have your project scope. The user scope aims to help you answer questions like how much resources am I consuming? How many hours have I used? How much storage do I have left? The project scope aims to help you answer questions like how much resources is the project consuming? Some upcoming features that you could look forward to would be exporting each of these tables as CSVs to help you with your own operational reporting. Another feature is self-service. Project leads will be able to self-service provision users and projects to significantly improve the turnaround time when creating new workspaces and assigning new researchers to these workspaces. Management Portal will also be the one-stop shop to complete your new user onboarding tasks and home to our new ADRF Password Manager to allow users to easily reset their workspace password. This concludes the Management Portal demo. Thank you for your time.
In closing, we want to thank you for your time today. Your ongoing support and engagement is crucial for our mission to enhance evidence-based policymaking for the greater good. Together, we can use data to make a meaningful difference in the communities we serve. If you have additional questions or would like to schedule a meeting with our team to discuss how the ADRF can be implemented in your organization, please reach out to us at info@coleridgeinitiative.org. By sharing knowledge and insights, we can collectively work towards more informed and effective policymaking. Thank you for your time.